replenishing the batteries once again to finish out my lecture. We're just about at the end here. I was mentioning that we should find the prime form for the 5 notes in the example, those 8th notes in the tenor voice. Find the prime form in the appendix in the back of your book. And here it is, 0, 3, 4, 5, 8. We know, for instance, now that we have calculated our prime form or set class correctly because it's listed here in the appendix. And it just so happens then that the Fort name for this is 5-Z37. Now I do want to make clear to you that I don't require you to list the Fort names, but I just want you to know that the Fort name is just this column here. It's 5-whatever. This right here is not the Fort name. This is the name of the set class or the prime form. So there's 2 separate things here. I always want you to be able to find this, the prime form. You do not necessarily need to know the Fort name, but I do want you to see that there's a distinction. These are not all one and the same thing. The Fort name is different from the prime form. It's separate. We could also tell, even though we weren't asked to do it, we can also tell that the interval vector for this pitch class set is 2, 1, 2, 3, 2, 0, which means that there are 2 instances of interval class 1, 1 instance of interval class 2, 2 instances of interval class 3, 3 instances of interval class 4, 4 instances of interval class 5, and no instances of interval class 6. One last thing I want to point out about the question in the self-test, and that's again back on page 516. There was one final question for number 5, and that question was, is the set that we found, the set class, is it inversionally symmetrical? Yeah. In fact, here's the question right here. Is the set inversionally symmetrical? Now again, you don't need to know too much about this, but I do want to point out that the answer is yes. The set class, the prime form, it is inversionally symmetrical. And the way we can tell that is from our calculations that we did just a few moments ago. Did you see how when we inverted this set, we got the same exact normal order as when we reduced our original normal order to start with 0. When the inversion starting with 0 and the original normal order starting with 0 are identical, then we can say that the set is inversionally symmetrical. Inversionally symmetrical. Again, you won't need to know that for the final exam, but I just wanted, for those of you that are techies, I just wanted to point that out to you. I think I might have enough time. I'd like to take this set that we found the prime form of, 0, 3, 4, 5, 8, and I know we already looked in the appendix for the interval vector, but let's go ahead and just review how to calculate an interval vector quickly. So 0, 3, 4, 5, 8 is what I'm looking at. And let me just put that out here. If I have the prime form, I like to find the interval vector from the prime form, which is exactly why I've listed it here. And let's start calculating or computing interval classes between each member of the set in any combination. The interval class from 0 to 3 is 3 half steps or a minor third, so that is interval class 3. The interval class from 0 to 4 is interval class 4. That from 0 to 5 is interval class 5. And finally, the interval class from 0 to 8, well, we don't have an interval class 8. And 8 is traditionally a minor sixth. So what is the inversion of a minor sixth? Well, that is a major third. And how many half steps are in a major third? That is a much shorter distance. So the interval class happens to be interval class 4 here. because the number of half steps in a major third is 4. Otherwise, you can just take 12 minus 8 and you can get the interval class. Okay, some other possibilities. Let's do this in a different color. I don't think I've done the distance from 3 to 4 yet. That's interval class 1, or 1 semitone. The distance from 3 to 5 is interval class 2. And the distance from 3 to 8 is interval class 5. 8 minus 3 is 5. 5 minus 3 is 2, and 4 minus 3 is 1. As long as when you subtract these integers, as long as you get an interval class or a number or a result that's 6 or smaller, then you're guaranteed that that's the correct interval class. How about another color? The interval class between 4 and 5 is interval class 1. The interval class between 4 and 8 is interval class 4. And finally, the interval class between 5 and 8, the last pair of integers in this pitch class set, is interval class 3. Wow, that's a lot of interval classes. And you know, when you have pitch class sets that contain 5 pitch classes like this, you should have a grand total of 10 intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right, we do. Now let's list them as an interval vector. And remember, the interval vector is just a string of numbers that lists how many instances of interval class 1, 2, 3, 4, 5, and 6 we have. Well, let's see, interval class 1, I've got 1 there and I've got 1 there. So it looks like 2. Interval class 2, I don't see any. Interval class 3, 1, 2. Interval class 4, 1, 2, 3. Interval class 5, 1. And interval class 6, 0. Do my numbers of instances of interval classes add up to 10? 2 plus 2 is 4, plus 3 is 7, plus 1 is 8. Oh, I missed something here. Oh, I missed an interval class 2. So there's 2 of interval class 1. There's 1 of interval class 2. There's 2 of interval class 3. There's 3 of interval class 4. Oh, and there's 2 of interval class 5. See, this is where it gets tricky if you don't pay attention. There's 2 of interval class 5. Alright, so now 2 plus 1 is 3, plus 2 is